Hi everyone, this is the last in this series of videos on volume. In this video we're going to look at the volume of composite solids. Let's have a look at what we've learned so far. We learned about the units of volume, and the volume of prisms, pyramids, and then finally circular solids including cylinder, cone and sphere. So before we look at composite solids, let's begin by looking at fractions of solids. The following shapes have a radius of 4 meters. Find their volumes. So you can see that they're both parts of spheres. So we want to use the formula 4/3 pi r cubed. This is a half a sphere or a hemisphere, and this one is an eighth of a sphere. So we're going to do a half times 4/3 times pi times 4 cubed, which is 134 meters cubed. And in this case here, we're going to do an eighth times 4/3 times pi times 4 cubed, which is 33.5 meters cubed. So let's have a look at the volume of a truncated pyramid. We're given the following measurements. The base length is 10 meters, the perpendicular height is 5 meters, and the height of the complete pyramid is 8 meters. So we're going to have to start by constructing the full pyramid. Now we can put the measurements in. So this distance here is 10 meters. This height here, from here up to the top of the truncated pyramid, is 5, and then from here up to the top is going to be 3. I've just done 8, take away 5. Now this distance along here will be half of that base length, so that's going to be 5 as well. Now what we're going to do is construct the right angle triangle there, and we need to figure out this distance here, so we're going to do similar triangles. Okay, we can do x over 5 is equal to 3 over 8. And multiplying both sides by 5, x is equal to 1.875 meters. Now that's that distance there. We need the full distance across, so we're going to double it, which gives us 3.75. Okay, so we're ready to work out the volume. I'm going to start by working out the volume of the big pyramid, so that's all the way to the top. So remember, volume of a pyramid is 1/3 times the area of the base times the height. The area of the base is 10 by 10 because it's a square. So it's 1/3 times 10 squared times the height is 8. And that gives us 266.7 meters cubed. Now let's do the volume of the top pyramid. So that's up here. 1/3 times, this is 3.75 squared, and the height is 3. It gives us 14.1 meters cubed. And subtracting the top pyramid from the big pyramid is going to give us the volume that we require, which is 253 meters cubed. Okay, let's move on to composite solids. An octagonal prism with a cross-sectional area of 12 centimeters squared is cut from a cylinder with radius 2.5 centimeters and height 5 centimeters. What is the volume of the solid remaining? So what we're going to have to do here is work out the volume of the cylinder and then subtract the volume of the octagonal prism. Now we're lucky with the octagonal prism, we're given the cross-sectional area, so we don't need to work out the area of the octagon. So let's start there. The volume of any prism is just the area of the base times the height, so that's going to be 12 times 5, which is 60 centimeters cubed. The volume of the cylinder is pi r squared h. R is 2.5, the height is 5, and that gives us 98.17 centimeters cubed. And subtracting our octagonal prism from our cylinder gives us our final volume, which is 38.2 centimeters cubed. Here's another one. Now remember, as well as subtracting volumes to work out the volume of a composite solid, we can also add volumes together. Like this example, we want to find the volume of this rectangular prism and add it to the volume of this rectangular pyramid on top. Let's start with the prism. So it's going to be length times breadth times height, which gives us 60 centimeters cubed. The volume of this pyramid is going to be 1/3 times the area of the base, which is 5 by 3, times by the height. So 1/3 times 5 times 3 times 5 gives us 25 centimeters cubed. And then finally, adding those two together, we get the total volume, which is 85 centimeters cubed. Here's another one. An ice cream cone has the following shape and dimensions. So it's constructed from a cone and a hemisphere. Find the total volume of the solid shape. Right, so we want to work out the volume of the cone and then add it to the volume of the hemisphere. Let's start with the cone. So remember, it's like a pyramid, so it's a third times pi r squared h. R is 3 and h is 11. And putting that in the calculator, we get 103.7 centimeters cubed. Now our hemisphere, the full sphere, has volume 4/3 pi r cubed, but we only want half of that. So we do a half times 4/3 times pi times our radius is 3, so 3 cubed. It gives us 56.5 centimeters cubed. Adding those together, and we get 160 centimeters cubed for the volume. Let's finish off with a practical problem. A cylinder contains 3 tennis balls, each of diameter 6.6 centimeters. Water is poured into the cylinder. If the tennis balls remain in the cylinder, how many milliliters of water will the cylinder hold? Okay, so we've got a couple of things to do here. We want to work out the volume of the cylinder and then subtract the volume of the spheres. Then we're going to have to do a conversion between centimeters cubed and milliliters. Okay, so let's start with how tall is this cylinder. So we're told that the tennis balls have a diameter of 6.6 centimeters, so the total height is going to be 3 lots of 6.6 centimeters, which is 19.8 centimeters. Okay, now we're ready to work out the volume of the cylinder. It's going to be pi multiplied by r squared multiplied by h. And you can see that I've put r in as 3.3 centimeters because the diameter is 6.6. Putting that in the calculator, we get 677.4 centimeters cubed. Now let's work out the volume of one of the spheres. So remember, the volume of a sphere is given by 4/3 times pi r cubed, which is going to be 150.5 centimeters cubed. Now we want to subtract 3 of these from the cylinder. So we're going to do 677.4 take away 3 lots of 150.5, which gives us 226 centimeters cubed. And then finally, we just want to convert this to mils. And 1 centimeter cubed is 1 milliliter. So the amount of water that the cylinder will hold is 226 mils. And that actually brings us to the end of this topic on volume and indeed our topics of measurement for years 9 and 10.